When you hear the word statistics, your mind probably jumps to, boring math classes, right? But what if it's not about that at all? What if it's actually a toolkit, a set of 5 core questions that psychologists use to literally decode human behavior? So that's what we're going to do. We're going to open up that toolkit and see just how they figure out the human mind, one question at a time.
I mean, this is the big one, isn't it? How do you actually put a number on things like focus, or anxiety, or even happiness? You can't exactly pull out a tape measure for that stuff. Well, the secret isn't some magic instrument. It's all about learning how to ask the right questions.
So let's do this. Let's imagine we're a researcher. We've just developed a brand new test to measure how well college students can focus. And now we're staring at a spreadsheet just packed with numbers. Where do we even begin? What's the very first, most basic question we need to ask?
Well, the first step, and it's just pure logic, is to get the lay of the land. I mean, before you can make any big claims, you have to understand who actually took your test in the first place. And that brings us to the very first question in our Psychologist's Toolkit. It's really that simple. Who are these people? What do their scores look like when you put them all together? To figure this out, our researcher needs to create a kind of snapshot of their data. And the tool for this job is called descriptive analysis. And the name says it all, right? It just describes the data. It's basically like creating a quick profile of your participants. Our researcher is going to calculate things like the average score, that's the mean, or maybe the most frequent score, that's the mode. We're just describing what's there. No big conclusions just yet.
And the result might look a little something like this. It gives you the average. And see that SD? That stands for standard deviation. It's basically a single number that tells you how spread out everybody's scores were. Were they all clustered together or all over the map? It's a really clear, concise summary of the who. Okay, so our researcher gets it. They understand their specific little group. But let's be real. They didn't invent this focus test just for the 200 students in their lab. They want to know if their findings could apply to all college students everywhere. And that leads to a much, much bigger question.
So how do you do that? How can you possibly take what you learned from one small group and make a solid, educated guess about a massive group you haven't even tested? This, right here, is where statistics starts to feel a little bit like a superpower.
This whole process is called inferential analysis. You're making an inference, a logical leap from your sample to the entire population. It's exactly how a political poll can talk to 1,000 people and get a pretty good idea of what millions are thinking.
Now check out how this finding is worded. The researcher can't be 100% sure, of course, so they create what's called a confidence interval. That's the CI you see there. They're basically saying, look, based on our data, we're 95% confident that the true average for all college students is somewhere in this range. That is a seriously powerful thing to be able to say based on just one small study.
But just knowing the average for everybody, that's not really the whole story, is it? The next logical step is to start digging for patterns, to start asking, are there any meaningful differences within my group?
Do freshmen have better focus than seniors? Do students in the arts program score differently than students in engineering? To figure this out, our researcher needs a new tool, one specifically designed for comparing different groups. And that is differences analysis. This is the absolute workhorse for so much research out there. It's what you use to see if a new therapy actually works better than a sugar pill, or if one way of teaching leads to better test scores than another.
And the toolkit has some really specific instruments for the job. If our researcher is just comparing 2 groups, say arts versus engineering students, they'd use something called a t-test. It's built for that. But if they wanted to compare 3 or more groups, like freshmen, sophomores, and juniors, they'd need a more powerful tool called an ANOVA that can handle all those comparisons at once.
So here's another example finding. Now, don't get hung up on all the numbers in the parentheses. That's just the statistical proof. The word you want to focus on is significantly. In statistics, that word has a really special meaning. It means the difference the researcher found is almost certainly real and not just some random fluke. This tool helps us separate a true pattern from just random noise.
Okay, so far, we've been putting people into different boxes and then comparing those boxes. But, human behavior is way more complicated than that. Things are interconnected. And that brings our researcher to the next big question.
Is a student's level of focus related to their GPA? Is it connected to how many hours of sleep they get? See, our researcher is no longer looking for differences between groups, but for patterns across different measurements.
And there are two main ways to go about this. The first is associative analysis, which uses a tool called correlation to see if two things just tend to move together. As one thing goes up, does the other go up, or maybe down? The second, predictive analysis, takes it a step further. It uses a technique called regression to see if we can use one variable to actually predict the other.
So using correlation, our researcher might get a finding that looks like this. That little R value, that's the correlation score. It tells you how strong the relationship is. In this case, it's moderate. But here is the critical point, and it's a huge one. This does not mean that high self-esteem causes better grades. It just means they're connected somehow. And this is where things get really, really cool. I mean, knowing two things are related is interesting, but using that knowledge to actually make a forecast, that's the whole goal of predictive analysis.
Let's use a classic example. Our researcher might run the numbers and find that SAT scores can explain about 16% of the differences, or what statisticians call the variance, in a student's first-year GPA. Now, 16% might not sound like a huge number, but in the incredibly messy, complex world of human behavior, being able to predict even a small piece of the puzzle, that's a massive step forward.
So, our researcher has described their sample, made an inference to the population, compared a few groups, and found some relationships. They've got results. But just getting an answer, that's not the end of the story. The final and honestly probably the most important part of the journey is making sure those answers are actually trustworthy.
And that brings us to the last part of the toolkit, the rules for good, solid science. Think of it like a pilot's pre-flight checklist. The researcher has to check their assumptions before they even run a test. They have to think about whether a finding is practically meaningful in the real world, not just statistically significant. They need to report the actual size of the effect. They have to deal with missing data the right way, think about errors in their measurements, and finally, try to see if their findings hold up in other groups of people. This checklist, this is what separates good science from junk science.
So, there you have it. From figuring out the who to predicting the what, we've walked through how 5 pretty simple questions make up this powerful toolkit for understanding human behavior. It's really more than just statistics. It's a whole way of thinking critically about the world around us. So, I guess my question for you is, now that you have the tools, what would you want to understand? What connections would you want to go explore?